Hello everyone, I am Monica Bhushan and today we are starting partial differential equation lecture number 2. So in last class we had discussed the introduction of partial differential equation, like what is partial differential equation, and in today's class we are going to see the formation of partial differential equation. We have to study formation of partial differential equation by two methods. The very first method which we are going to cover in today's class is by eliminating the arbitrary constant, and the second method is by eliminating the arbitrary functions, which we will be covering in coming classes. Okay, so here we have to form the partial differential equation. So very first thing is, what is partial differential equation that we are going to form? So in partial differential equations, we will be dealing with multivariable function, correct? So multivariable function, here in this set of questions, they have mentioned that this z is a function, fine. But this function is not a single variable function. The function depends on two variables, and these two variables will be actually independent to each other. Partial differential equation, we have to deal with multivariable function and the relation between partial derivatives of this multivariable function. Okay, fine. So but very first thing, before jumping to the formation of partial differential equation, what method we are going to study today? The method is by eliminating the arbitrary constant. So very first question arises that why I have to eliminate the arbitrary constant, and what is arbitrary constant right now? That are we aware of arbitrary constant? What is difference between normal constant, independent constant and arbitrary constant? So those things first we will clear, and then we will come to the formation of partial differential equation. Okay, so why it is written specifically arbitrary constant? Because as we have just now discussed the definition of partial differential equation, there we don't have the arbitrary constants right in that equation, right? Suppose this equation, if we will be focusing on, that means this is something, some relation is given, right? And then we have to form the partial differential equation of this given relation. Very first thing is, yes, this is the equation, equal sign, left hand side, right hand side, but this is not partial differential equation. Partial differential equation shows the relation between partial derivatives of z. So we had seen, right, del by del x of z and del by del y of z. So some specific name also we had discussed last class. Del by del x of z is p, del by del y of z is q, and these notations p and q actually have been given by different authors, and this is the standard notation. If you really don't want to use p and q, then if other name you are using, you have to specifically give the different name and the definition and all. So better to use the standard name. So they are del by del x of z is p, del by del y of z is q, right? We have seen these things. Okay, my job is to convert this given equation into partial differential equation, but the method which I am going to follow is I have to eliminate the arbitrary constants. Okay, so first thing is, we know constant, right? If I'll talk about, if I want to give you the difference between constant and arbitrary constant, so if I'll talk about pi, right? So mathematical notation, pi is what? This is 22 by 7. Okay, so 22 by 7 is also a constant, but whether this is some constant or this is arbitrary constant, so constant will take one value. Yes, pi is taking one value, but this pi will always take 22 by 7 value only. Okay, it doesn't mean that in one equation you are going to put the some arbitrary value, something which is I mean a user is allowed to choose. That is not the case, right? So that means this value is not arbitrary constant. Okay, so pi 22 by 7 is not arbitrary constant. Okay, so what is arbitrary constant then? When I am allowed to choose any value specifically for my equation, or specifically for the present situation, that will be called as arbitrary constant. Suppose I'll talk about what is even number, right? Then you will say that 2 into n is even number, right? Why? Because this is divisible by 2, and where n is arbitrary constant. Okay, why n is arbitrary constant? Because it depends on you, that you are going to choose either n value 0, either n is 0 or 1 or 2 or 3. That means the whole number, any value you can choose. Even if you are choosing 0, yes, you are going to say that this is even number. Even if you are choosing 3, yes, you are going to say that that will also be even number. Correct? So in this case, n is arbitrary constant, where you have the freedom to choose any value for that, but that the constant which is independent constant and which is not arbitrary, that will also take one value only, but that value will be always same. So this is the difference between independent constant and arbitrary constant. Okay, now we will be solving these three questions in today's class, and this method, that formation of partial differential equation by eliminating the arbitrary constant, will be done in next class also, because in next class we will be taking the example where the arbitrary constants will be more than independent variables. Okay, and in today's class, in each and every equation, if you are going to see, suppose again focus on this first equation. So total number of arbitrary constants are 2, that is same as total number of independent variables. Okay, because since we have seen the previous class, so we have the idea, we know that what is partial differential equation. For partial differential equation, x and y are independent variables and z depends on x and y. Correct? No? Fine. And we have two independent, and we have two arbitrary constants also given. Fine. Now, so in today's class we will be seeing all those questions where always if two independent variables are there, so two arbitrary constants are there. I mean, total number of independent variables and arbitrary constants are same. And in next class we will be seeing that total number of arbitrary constants are if more than total number of independent variables. So what will be the case? And the question related to sphere. Okay, fine. So now we will be solving the very first question. Fine. So this question is given to me, and they have asked us, like, we have to form the partial differential equation. Okay. So very first step is what? Always my first step to form partial differential equation is, since this is partial differential equation, so very first thing is find the partial differentiation. Okay, so I'm going to find the partial derivative. Okay, so I'm going to partially differentiate the equation, but partially differentiating the equation with respect to what? Okay, so that means what? This is the function, z is the function, right? No, so z is a function. Okay, so this function only I'm going to deal in my equation. They have given us z only. Since two independent variables are given to me, so I'm going to find out partial derivative with respect to x and partial derivative with respect to y. Fine. Okay, so for that what I'm going to do? So now this equation is there. This is my 2z equals x square by a square plus y square by b square. So very first step is I'm going to partially differentiate this equation with respect to x and with respect to y also. So how to find the partial derivative? So what I'm going to do, this is your 2 del by del x of zy, because the very first time I'm going to find the partial derivative with respect to x. So both sides, left hand side and right hand side, I'm going to differentiate partially with respect to x. So this is 2 del by del x of z equals what? It will be your del by del x of x square by a square plus del by del x of y square by b square. Correct? No? So then this is what? This is 2 into, now del x by del by del x of z is what? We have given the name. Del by del x of z is nothing but p. Okay, So for easy writing, I'm just writing down P here. Instead of writing del by del x of z, I'm just writing down P. Okay. Now, this is what 1 by a square is the constant, so I am taking out, and then del by del x of x square will give you how much? 2 into x, that is correct, plus this is 1 by b square, even y square, both are constants, right? Why? Because if I am finding out partial derivative with respect to x, so in that case, whatever was constant or whatever was arbitrary constant, that will be constant only, but all other variables will also be treated as constant. This is only partial derivative definition, correct? No. So in that case, if I'm finding out partial derivative with respect to x, so y I will be treating as constant, and b, we know that b is arbitrary constant only. So this complete thing is constant. So del by del x of constant will give you 0. Fine. So that means this is nothing but 2p is 2x by a square. Okay. Now what next I can do? I'm done till here. Now they had said that form partial differential equation by eliminating the arbitrary constant. So what I'll write down, this arbitrary constant I will write down in terms of all other things. So a square will go up. So a square will be how much? 2x by 2p, or a square is nothing but x by p. So a square is x by p. Till here we are done. Okay, so and why we have done like this? Because finally I have to eliminate from this given equation a square, and I have to eliminate in this given equation b square, and then whatever value I have got, that value I'll just put here, then I will get the answer. Because the answer allows us to have z, answer allows us to have this constant, okay, because this is not arbitrary constant. 2 is not arbitrary constant, 2 is just independent constant, and this equation will allow us to have x also and y also. So my next job is I'm going to partially differentiate the equation with respect to y. Okay, so the equation is written here. 2z is x square by a square plus y square by b square. Now, I am going to take partial derivative with respect to y. So that means del by del y of z, left hand side, is what? Del by del y of x square by a square plus del by del y of y square by b square. Fine. So left hand side I can write 2 del by del y of z. Remember, we have given the name as q. Del by del y of z will be q. This is nothing but again del by del y of what? This 1 by a square is again, this is one arbitrary constant, and this is again x square. So x I am going to treat as constant because I am going to partially differentiated with respect to y. So in that case, x is a constant. So this complete term will become 0. Why? Because differentiation of a constant is nothing but 0, plus 1 by b square I am taking outside, and then del by del y of y square will give you how much? 2 into y. Fine, no? So that means this is what? This is 2q equals 2y by b square, or this is q equals y by b square. What next I should do? Since I have to eliminate the arbitrary constant, so I'll just write down what is b square. So b square will be y by q. Okay, no? So b square is y by q. So I got what is a square, I got what is b square. So finally in this given equation, I'm going to replace a square with x by p. So if you will see here, okay, so what here we are writing down? 2z, this is left hand side, equals x square into 1 by a square. So 1 by a square will be how much? Will be p by x. So x square into p by x plus y square into 1 by b square. 1 by b square is q by y. So y gets cancelled, x gets cancelled. So this is 2z equals px plus qy. Okay, so but if whether this is my required partial differential equation, so as per the definition of partial differential equation, yes, the equation is containing the multivariable function, not necessarily the function will always be present, but it is present, that is also okay. Okay, and it is containing the relation between partial derivative of that multivariable function. So x, y, p, q, z all are allowed. Not necessarily they all will be present in all your partial differential equation, but they are allowed. And even this constant, independent constant is also allowed, but arbitrary constant is not allowed. So this equation we have formed into this final equation. Okay. Now we are going to start the second question. So it is given us that that z is a log x square plus y square plus b. Fine. So very first thing is what? If I have to find out partial differential equation, that means partial differential equation. That means I am going to find the partial derivative, but partial derivative of that function which is my z, which is multivariable function. So I'm going to find with respect to which all variables. So all those variables which are present in the given equation. My step number 1 is what I'm going to write down. First I'm going to write down the, as it is the equation, z is a log x square plus y square plus b. Then I'm going to find out partial derivative of z with respect to x. Then I will find partial derivative of z with respect to y also. So if I am finding out with respect to x, so what will be there? Left hand side I have written down del by del x of z. Right hand side is what? A I am taking as constant, and then del by del x of log x square plus y square, okay, plus del by del x of b. Now del by del x of z is p, we remember this notation, and this is a constant. Del by del x of log something is what? This is, if I'm finding out derivative, so it gives me what? 1 by that thing what is present inside my log. So this is 1 by x square plus y square, and then this is your 2 into x, and then y square I'm going to treat as constant. So it will be just 0 only, correct? No, so I'm not writing down this part. So this is nothing but 2x only. Fine, because y square is constant with respect to x. Fine. Plus del by del x of constant will give you 0. So finally you got p equals 2ax by x square plus a square. Okay. Fine. So this is my p. Now what actually we have seen in the previous example, that if I'm going to replace this arbitrary constant, okay, with the given whatever the we have got the result. So that means what I should write down here? A should be actually x square plus y square into p, fine, divided by 2x. Okay. Now the second thing is what? I'm going to find out del by del y of z. So del by del y of z will be what? This is the equation given, right? No. So del by del y of z is what? A into del by del y of log x square plus y square plus del by del y of b. That means A, so del x by del y, I mean del by del y of z is what? Del by del y of z is q. The notation we have to memorize, and this is A into, again this is what? 1 by x square plus y square, and with respect to y, x square I am taking as constant, and this is nothing but 2 into y. Fine. Plus this complete thing will become constant, so this is your 0. So finally you got what? This is q equals 2ya, okay, 2ay or 2ay, better to write just because the constant I am taking prior. So 2ay divided by x square plus y square. Okay, but here you will find that where is my b? Okay, so because here I have written down a is something, because I want to replace a with this complete thing, and similarly I want to replace b with whatever I should get, but actually b is not present here in my final answer. So because of that only, better to have this consideration in your mind, that since p is your 2ax by x square plus y square, and q is 2ay by x square plus y square. So I can write down some other fashion also, because my job is actually to eliminate the a. Okay, because b is already not present, so I have to eliminate a. So for that case, what I'm going to write down? So we can see that both places we have x square plus y square. So if I will find out what is my x square plus y square, in this equation, this is 2ax by p. And in this equation, same thing, x square plus y square is nothing but 2ay by q. Okay. So in that case, 2a gets cancelled. So I can say that x by p is nothing but y by q. Okay, the same thing you can write, or you can write down xq, okay, equals yp, or you can write down this qx xq, whatever you write down. So qx minus py equals 0, because both things I have taken in the left hand side. So here we got qx minus py equals 0, or both, anything is okay. So qx minus py equals 0, or py minus qx equals 0, both are same. Why? Because this also, what we have got here, this is also saying the same thing, right? Py equals qx. This is also saying the same thing, py equals qx. So this is, you can say that this is your required partial differential equation. And what method here we have used? Here, totally up to you. The goal is you have to eliminate the arbitrary constant. But here what they have done, so since these two equations right now, what we also have got, they have just divide just this 2 by 3. So they have divided 2 by 3. So in that case, that is also correct. So x square plus y square will get cancelled. So p by q will become my x by y. So both are actually same. Okay. What we have done, this given equation we have rewritten in terms of partial differential equation form. Okay, fine. Now we are going to see the last question. This is z equals xy plus y under root x square minus a square plus b. Fine. Should be my step. The very first step is I have to find the partial derivative of z with respect to x and with respect to y, because only two variables are given to me. And then finally I need to eliminate a, and I need to eliminate b from this given equation, and then whatever form I will get, that should be my correct answer. Okay, so very first thing is we are differentiating with respect to x first. So z del by del x of z is p. P is giving me how much? So x, y. So that means y is constant, and del by del x of x will give you 1. So y plus, I mean, if I'm writing down del by del x of y into x square minus a square, what I should get? So this is nothing but y I'm taking here, and then del by del x of under root x square minus a square. Okay, and then plus under root x square minus a square, and then del by del x of y. So del by del x of y will give me 0. So this complete term will become 0. Correct? No. So only I have to work on this term. So this is what? Y into del by del x of, this is right. Del by del x of, you can say that x square minus a square to the power 1 by 2. Fine. Del by del x of x to the power n should give you n into x to the power n minus 1. So what I am doing, y is present here, and then 1 by 2 into 1 by x square minus a square to the power half. Half minus 1 will give you minus half, so it will go into the denominator, and into 2 into x. Fine, correct? So 2 and 2 gets cancelled, so it is nothing but x into y, correct? X into y divided by x square minus a square to the power half, or under root, you can say x square minus y square. And then one y was already present, correct? So this term y was present, this term we have got, and this will become 0. So finally we got del by del x of z is this much. Okay, now what is my del by del y of z? So for del by del y of z is called as q, right? The left hand side is q. And what about my right hand side? So in right hand side here, if we will see, so in the right hand side, del by del y of this term will give you how much? It is going to give you, the very first term is x only. del by del y of this complete thing, that means this is nothing but the constant only, okay, and then y. So writing here, okay, so the right hand side you can see here, this is what del by del y of xy plus del by del y of y under root x square minus a square plus del by del y of b. So this will give you x only, okay. So plus this is what this del by del y of y into constant, correct? No, because if I'm talking about y, that means x I'm treating as constant, and this is already constant. So this I have taken outside, under root x square minus a square taken outside, and del by del y of y will give you 1 only, plus del by del y of constant will give you 0. So finally you got q equals x plus under root x square minus a square. Fine. Now next what I should do, see in this case also, this what we have got here, p is y plus xy by under root x square minus a square. I don't have b here. Similarly, q equals x plus under root x square minus a square. Even here also I don't have b. So what I can see here, that this term is present in both places. If I'll come to know what is under root x square minus a square from this equation, and then I will substitute in the second equation, I will get the required answer. Correct? No. So if first equation I'm writing down, first equation is what? P minus y equals xy divided by under root x square minus a square. That I can write, right? Because y has gone to left hand side. And then this is what? X square minus a square under root x square minus a square is nothing but xy divided by p minus y. And if I will substitute on this part, under root x square minus a square, if I will substitute here x plus xy divided by p minus y. So that means x, if I am taking common, so this is p minus y, and then p minus y, and then plus y. Y gets cancelled, so it will become q equals x into p divided by p minus y. And then I can actually here, because all those things are allowed in my equation, so I can rearrange and I'll get the answer. What we have done here, so q minus x, okay, the very first equation, q minus x is under root x square minus a square, and then we are using the above into the second equation, and then finally we have got here also the same thing. This method also we can use, and then finally same answer we are going to get. So here also this is pq is xp plus qy, here also pq is xp plus qy, so both are same. So fine, so this is actually required partial differential equation. So in next class, we'll solve some more questions. So if you find this class useful, please like and subscribe my channel. Thank you.